In this video, we're going to take a look at a couple different ways that we can reverse engineer less than desirable scan data. So we can see here on screen, we've got a part that's a really rough, low quality scan with some obvious misalignment to it. So the first thing that we're going to do is we're going to go ahead and try to determine a center axis based off of a series of scans that are all linked together that we know to be somewhat true to the shape of the part. So you can find this lesser quality scan data from either lower quality scanning systems, or there may just be certain situations where you're unable to get a really good surface off of a part that's clean and accurate for a variety of different reasons. So while we generally want to work with the best quality scan data possible, sometimes that just simply isn't the case. So once we build out our center axis and we create a little bit more reference material to be able to align our part up, the very first thing that we want to do when we're dealing with lower quality scan data is we really want to make sure that we get a coordinate system locked in place. That'll be very beneficial later on. The second thing that we want to do is create a series of stacked sections, which you can see here in this sketch. We're using about 40 different sections to define this part, and we can see that there's a very large distortion on the outside diameter of our part. However, on the inside diameter, or that inside profile, we have a fairly clean and reliable surface. So we're going to use that inside surface as our driving surface for our part, and then for the outside surface, we're going to go ahead and use the innermost portion, as we can most likely determine from this part that the outside surface is going to be one particular thickness that's thinner than the rest of the part, or when the object was scanned, the misalignment caused it to become thicker than it truly was. So we'll sketch this out. We'll get our sketch trued in to where we feel like it's appropriate. And then from there, the process is pretty much the same as any other reverse engineering application, where we build out that solid, revolve, and then modify things as need be. And then we can go through and trim that out into the desired shape. So we'll use a couple of planes just to trim that out. So the way that we modeled this first, we can already start to see that we're very close to the true accuracy on the top portion of our part. However, down here on the bottom portion, we can start to see where it shifts out, and we'll see that a little bit more clearly here in a few moments. So that is reverse engineering it fairly closely to the way that we see the model, which can be really useful in a lot of applications. However, because this is reverse engineering, we can start to look at design intent on our part and make a couple of other adjustments in order to maybe make this part a little bit more accurate to what it actually should be, rather than what we're visually seeing in our scan data, which will be the second portion of sketching that we'll go to here in just a moment. So we'll finish trimming out this part, and then we're going to take a look at it and then move back into our sketching process. So we'll get this final trim, and there is a good representation of how clear or how accurate the part is to itself in that one particular location closest to the plane. And then this opposite side, we can see that very large deviation. So we've built out a CAD object, but one thing we'll notice is that CAD object has a lot of varying thickness on it. Well, we could be safe to assume that this is probably supposed to be a bent sheet metal part. And in being a bent sheet metal part, we know that the thickness should be relatively uniform all the way around, especially when being built out as a CAD model. And there are some exceptions to that, as far as the radius bends being a little bit thinner than the rest of the material. But for the purposes of this video, we'll just keep everything equal. And to do that, we've gone through and we've resketched this object. We've also determined a center line that we're mirroring around. So we have equal distance sketches. We have a mirror line that we're centering around, which we'll notice that the inside diameter is now going to be different than what it originally was. And it's going to be a little bit different to what the scan is showing us. However, we have a much more uniform part that we're working with. And when overlaid to our scan file, we can see the contrast of these two parts. So you can definitely reverse engineer off of really rough scan data. One thing that is a little bit more critical when doing this is having a much better understanding of design intent of the part moving into this process to make sure that we're making the correct adjustments accordingly. So thank you very much for taking a look at this video, and if you have any other questions, feel free to let us know.